Welcome, friends, to Answer Everywhere. It's Meme Gen Monday, and today we're taking a look at the source code for Flutter, which is Google's multi-platform UI development kit. Maybe kind of an answer to React and React Native and that sort of thing. The idea is that you write your apps in Flutter, and you write the UI as code rather than as maybe something like XML that gets inflated by code. And the rendering system somehow takes that UI and understands it and optimizes performance for the screen. So we'll take a look at it. We did a video on React, which you may want to also take a look at if you haven't seen that. And yeah, so we'll jump into the code. So here's GitHub. I believe this is where Flutter lives. I don't think this is a mirror. And so let's talk maybe a little bit about what we expect to see. First of all, we expect to see everything's kind of like a giant graph. The idea of Flutter is everything is a widget, and those widgets are somehow going to be nested into each other. We're going to have to figure out how to keep track of state in the widgets. And the widgets are also going to have some sort of behavior. But ultimately, I think the algorithm is going to be about walking some tree of widgets, rendering the things that have changed, and not rendering the things that have not changed. More or less the same sort of algorithm that we saw in React. It should be written in Dart. I think let's actually verify this. Yeah, okay, so 99.1% Dart, a little bit of C++ and some other things, probably Java for Android, Objective-C for iOS, maybe, for iOS, maybe Mac OS. Yeah, so I guess what I'll try to do is see if I can figure out more about where the main rendering logic is, and maybe try to branch out from there. I imagine a lot of stuff is kind of just building out the library of widgets, which are, I'm sure, interesting, but a lot of it's going to be customizing a common inherited widget object, which is going to be given different functionality for different things. I'd also kind of like to see where maybe some of the drawing logic. I'm not sure if there's any generic Dart drawing logic, or if the Dart code just kind of hands off to the relevant platform library. So we'll try to see a bit of that. That'll be kind of my goal going in. And we see in the main page we've got the kind of usual suspects here in the main repo. Packages is where I'm going to guess most of this stuff lives. There might be something in bin. Let's just check what bin is. Yeah, bin looks a little bit important. We've got some bat file, which should be some sort of Windows batch file. And we've got internal. Okay, we've got stuff about some stuff about engines and Fuchsia. And okay, cool. So let's look at packages. And okay, so we've got packages / Flutter and Flutter driver and Flutter tests and Flutter tools and web plugins and more Fuchsia stuff, Fuchsia remote debug protocol. And I'm going to guess that packages / Flutter is where we want to be. Although, what was this thing? Wasn't there a thing about a driver? Was that in the other one? Flutter driver, here we go. Let's see if these folders have readmes. No, we have this pubspec, which I think is the Dart kind of version of a lock file for, or maybe just a dependency file for its dependencies. I guess let's just peek at one just to verify that. Yeah, so we've got lists of dependencies, some constraints on environment. This line is auto-generated. Okay. So let's see. And then in Flutter driver, maybe lib, driver extension Flutter driver. Let's just take a look at what Flutter driver.dart is. This provides the API to test Flutter applications that run on real devices and emulators. So I'm guessing driver means something more like test driver rather than driving the overall Flutter engine thing. So we're going to ignore this for now. So here we are in packages / Flutter. We've got lib and some test stuff and Dart test. So I'm going to guess lib is the place to be. And this looks promising. You get a source file, a source folder. Cupertino, which I recognize as like Dart or Flutter support for like Apple, and not like look and feel, I guess you would call it. Cupertino being the city or town where Apple is, I think, headquartered, or at least where some of their big offices are. And we have painting and physics and rendering and scheduler and semantics. These all look very promising. So I guess what I'll do is I'll open this up and I'll open up all of this stuff that looks kind of like drawing related, like painting, drawing, rendering, scheduler. And then I'm not sure about semantics. I'll open it up here. Gestures, I think I'll ignore. Animations might be interesting. And then I'm going to look in source to see if source has anything else especially interesting. Okay, so in source, we see a bunch of the same folders kind of repeated that we saw the file versions of before. And so I'm going to guess that this is the right place to be. I'll close out. No, I won't. I'm going to keep this folder open just to remind myself to return to it. Here's the root of packages, Flutter Goldens. I'm going to guess this is about golden test files. Localizations, I think we can ignore tests, tools, integration tests, and analysis options. Okay, so I think we can ignore most of that stuff and really focus on this packages/Flutter directory. And that's what I'm going to do. And I'm going to go to the chat because I see some stuff scrolling by. All right. Hi, MSA. Hi, Raxnef and MSA and Suman. I'll just look at these in order. So Suman says you should take a project and explore it for a week. Taking random projects and opening random files for 1 hour is silly, and I'm kind of disappointed in the video's quality. Quantity is less than quality. And then MSA was just saying hi. Yeah, hi MSA, welcome. Hopefully you enjoy this. And then to Suman's point, I think there's some wisdom to exploring a project for a week, and I've thought about doing that for some projects. Certainly, the general theme is that we are going to return to some core projects repeatedly. I think we've done a few episodes on some of the browsers. We've done, I think, a couple episodes on some of the Linux stuff. But just because we have a bunch of stuff to get through, at least initially, we aren't going to always return in the next few days. As for the rest of your comment, I'm going to try to interpret it charitably. The approach I'm taking is the approach that I think is, in my experience, the most productive way to get a feeling for our code base. People have suggested all sorts of other approaches. These are all things that I've tried in the past. They work okay. They're not as great to really getting a feel for what's going on in the code. And in terms of like, if we were actually intending to use the code that we're looking at, then there are a few things I would do differently, but not a whole lot. And as I've mentioned elsewhere in other comments, first of all, the opening of files is not random. It's deliberate. There's some element of uncertainty around everything, and then kind of as we go through the episode, we close down the uncertainty and start to really get our bearings. So that's one thing. And the other thing is, since the beginning, this show has been about. I guess maybe I compared it to I forget the name of the show, but those wilderness shows where you take a wilderness expert and you kind of drop them into a new setting, and their thing is they're trying to figure out how to get it out of where they are, and so I think that's a skill. I think it's a skill worth developing, and for whatever reason, when I started doing this, I did some kind of test runs of different sorts of content, including live coding and doing this sort of thing. And personally, this was the thing that I liked watching the best. And so that's what I went for. And we'll eventually do other sorts of things here, but that's what this particular show is about. And the reason for, maybe one more thing I'll say is that the reason for looking at a lot of different projects is that psychologically, the way that the brain works is that it kind of does integration over examples. And so by looking at different projects, over time, the folks who follow the show are going to get a sense of how the open source world works in general in a way that I think is going to be deeper than if we just focused on like one thing and stayed with it the whole time, kind of the way you would in a college semester course. So, I mean, I'm sure we've all had the experience where the kind of like semester long college courses that do a deep dive in a thing, you often like really feel like you're understanding it while it's going on, but then you forget all of the details, and that's not unpredictable given kind of what we know about the way that brains work. So that's kind of where I am. I appreciate the feedback. I appreciate when people let me know things that I can do differently. In this case, this is a thing that I've deliberately decided that this is the way that I want to do it. So Racksneff is saying, okay. So Racksneff is saying they would like to see me do some live coding. I will do some live coding. I intended to get to it a little bit earlier, but just workload issues. I need to make time for it. I'm also working on a couple of other sorts of content in the background, and I'm also working on building stuff that's not public. So I've got a lot going on. I'm optimistic, mildly optimistic, that we'll get to live coding maybe next week, possibly this week if things go super well with all my other stuff. But it's coming soon. And that was always kind of my intention. It was not just supposed to be about reading other stuff. The reading of other stuff was meant to be also like an input into how we understand the stuff we're building as well. And then so Cole is saying, watching you go into a code base, give me some tips on how to read code I didn't write. Thanks, Cole. I appreciate that. I've heard that from a ton of people, by the way. I do occasionally get the kind of the feedback, and I think Suman is either watching or was watching and is showing up here because they're interested, and so I appreciate that. But I do sometimes kind of get these drive-by comments where a couple of people have said this do this other way, but I do think the vast majority of comments have been people who really like what we're doing. So it is niche. I was always expecting it to be niche, but I'm happy with this is the way that I think that I think this is a cool way to do things, I guess is what I'm saying. So I appreciate that. Cool. Okay, so back to code. I don't want to be in painting first. I want to be in what? Maybe semantics. Semantics, services, or widgets. I guess let's try. Did I not open these? Maybe I didn't open these. Well, let me jump back a directory here and open semantic services and widgets. And I think scheduler is important too. I might have already opened that, but I might have thought this was like just a painting schedule. This might be more general. Okay, these are just going to be imports. We have binding, priority, service extensions, and ticker, and a comment. The Flutter scheduler library. This library is responsible for scheduling frame callbacks and tasks at given priority. The library makes sure that tasks are only run when appropriate. Okay, so that'll be interesting. I'm not sure that that's the heart of what I want to see. Here's this Flutter semantics package. The The semantics event classes define the protocol for sending semantic events to the platform. The semantics node hierarchy represents the semantic structure of the UI and is used by platform-specific availability services. Okay, I'm not sure still yet where the cool stuff is. Here's services. These are platform services exposed to Flutter apps. So probably by platform, I'm going to guess they mean like platform dependent. I think I might have just lost my chat window. Yeah, thanks, Rexnap. No, I appreciate it. I'm excited to get to the coding stuff. So you're not rushing me at all. Okay, so here's services.dart. And again, we're just looking at imports, but I've already opened the file, so we might as well take a little bit. Oh, sorry, these are exports. That's what I meant. So let's see. So we have things like keyboard events, haptic feedback, which I guess is like when your phone buzzes or whatever as you type something. Binary messenger. I'm not sure what binary messaging is. We've got some sort of binding, which we've seen in all of the stuff. Android keyboards, system channels. I'm not sure what exactly that could be. Things like text boundaries and text editing, and undo manager. All right. That should be platform specific, kind of interfacing with the more maybe low level code. Here's widgets.dart. Let's just look at what it's exporting. We have things like autocomplete, banner, basic, presumably some sort of basic widget, dismissible part, focus manager, heroes, I guess hero images. And do we have like, what's a basic Flutter one, like stateful? I don't know. Okay, but there are lots of widgets. Scroll notifications, router. So I'm going to ignore widgets for now. I don't know whether semantics is important for sending semantic events. Let's take a look at maybe a couple of the semantic stuff and see what they're calling a semantic event. Should we look at semantics events? Here's semantics.dart. We have assertiveness. The assistive technology will speak changes whenever the user is idle, which is polite, or the assistive technology will interrupt any announcement that it is currently making to notify the user about the change. Okay. That's like a thing for configuring speech to text, I guess, or text to speech. So here's a semantics event, an event sent by the application to notify interested listeners that something happened to the user interface. For example, a view scrolled. These events are usually interpreted by assistive technologies to give the user additional cues about the current state of the UI. Okay, so I'm glad they have this message here about assistive technologies, because otherwise I would have just thought that like this was for listening to for all of the UIs who wanted to listen to things like the fact that the view scroll. But I don't think that that sort of stuff should be handled, I guess, by the rendering algorithm. And so this is maybe semantic in the same sense as semantic web, that these are like meaningful events that other apps can process. And here's semantics.dart, which we'll ignore. So I'm wondering, I'm developing a feeling that where I want to be is in scheduler. Let's take a look. Maybe foundation. What's foundation? We have bit fields, bit field web, binding, basic types, collections, consolidate responses, constants, isolates. Yeah, this looks important. The rule for packages in this directory is that they can depend on nothing but core Dart packages. They can't depend on Dart :UI. They can't depend on package, and they can't depend on anything outside this directory. Currently, they do depend on Dart UI, but only for void callback and maybe one day lerp double. I don't know what lerp double is, which are all intended to be moved out of the Dart UI into Dart core. Okay. So we have stack frame. And let's also actually do a quick look at scheduler. We have priority and ticker. Let's look at priority and ticker. So we looked at the priority code for React, and that was done using something that looked pretty custom to me, which, if I can remember off the top of my head, well, lanes, they called them, and then they had this kind of like large job struct that they called something whose name I forget. And lanes were kind of these bit fields that were used to encode priority information. And the overall rendering algorithm, as I'm trying to remember off the top of my head, and you can go look at the video and we talk about some of this, is they essentially had two linked lists, which they were using as a kind of like a double buffering situation, where one list represents what's on the screen and the other list represents the next desired behavior. And then they use the priority information to kind of first render, when it's time to swap them, essentially, they use the priority information to first render the most important stuff. And then I guess in another pass, they render the less priority stuff. But they try to do this with, by essentially, at least conceptually, taking a diff between the two things and just applying what needs to change. React Fiber, yes, MSA, thank you. React Fiber is the name of the job, the job scheduling thing I was mentioning. All right, so I expect priority in Dart and Flutter to be different. So let's take a look at what they do. Okay. So a task priority has passed a scheduler binding schedule task. So what is a priority? We have a class, which I'm going to think of as basically a struct with behavior. This must be, I guess, like a constructor in Dart. I'm not sure I remember exactly how constructors work in Dart. So we have an integer priority value. So this is in React. They had priorities were, I forget exactly what the type was, but it was a list of bits, which is, of course, a way of representing an integer. But they didn't seem to be thinking about them as integers in the sense of, integers have an ordering. They start with 0 or 1, or I guess natural numbers start with 0 or 1, depending on your inclination. And then you have this ordering where everything's the successor of some number before it. But they were using the fields more like so they're called lanes. So I guess you're supposed to think of them as like swim lanes, where like there's a one here means you're in this lane, or you're maybe also in this lane, but you might be in some other lanes as well. So they were using what I think were ultimately integers, but they weren't using them in the normal integer way. So we'll see what what Flutter does. We've got some idle task, a task to run after all the other tasks when no animations are running. Okay, do we have just a single idle task? And priority is immutable, which makes sense. You don't want, if you mutate the priority, then your priority algorithms, I guess, have to recalculate. So it's nice if they can assume that the priorities are immutable. So Ragsnap is saying, just for information, I think a variable or method in Dart starting with an underscore are private. Yes, I think that's correct. What I don't know is so this is priority. And we've got the underscore here, but it's also being called on this underscore value. I'm just not sure what this particular construction is, but I think you're right. These should be private. I don't know if this is enforced. Like I think in Python, that's a convention, but you can actually peek at everything. We also have animation, which is a task to run even when animations are running. We have touch, a task to run even when the user is interacting with the device. Okay, so we are doing something different. So here's priority. What is this? Is this 100,000? There's 3. This is 100,000. And then we have 200,000 for the touch. So what does this mean? I'm guessing, so based on the comments, this is not like necessarily just the priority for an animation. This is like kind of maybe like the animation lane. This is like a category of things They're like, even if animations are running, you can also do other things. And if you want to do those other things, you put them in, you give them with this priority, and this priority is 100,000. And touch has twice the priority, a task to run even when the user is interacting with the device. So I don't know if, so 0 is idle. So that's when nothing is running. And so I'm going to guess increasing numbers mean increasing priority rather than vice versa. You could imagine 0 being the highest priority, as in some bug tracking systems, for example. But I think higher numbers are higher priority here. And touch, stuff that runs when the user is interacting is twice as important as animation, I guess is what I'm getting here. But you can kind of see maybe some of the lanes similarity, because idle, animation, and touch are kind of like classes, I guess, of priority, is maybe one way of thinking of it. We have some offset, maximum offset, by which to clamp relative priorities. It's still possible to have priorities that are offset by more than this amount by repeatedly taking relative offsets. But that is generally discouraged. I don't know what it means by to clamp relative priorities. I guess relative meaning like foo is more important than bar, but they might not have numerical numbers at some point. At any rate, this is set to 10,000. So there's some sort of like granularity of priority. And then we have a priority, we can return a priority relative to this priority. Okay, a positive offset indicates a higher priority. The parameter offset is clamped to plus or minus k max offset. Okay, so we've got some operator plus. Presumably this is overloading the plus operator. So we can do priority A plus priority B, or just, A plus B if A and B are have type priority. And then we look at the offset, check whether it's bigger than the maximum, in which case we just use the max offset times the offset dot sign. I guess sign is like whether A is, this is the thing being passed in, right? So I guess if we do A plus B, we're looking at B's sign, and that might be negative if B is less, has less priority than A or something like that. And then we're going to return the priority of basically taking the offset and the value as integers and promoting them to a priority object. And we can get a priority relative to this priority with minus. Okay, and so this is just the opposite of plus, I guess. I think that's what's going on. Let's see what else is in scheduler. Let's look at one of these binding files. There's stuff about frame callbacks, task entry. This looks important. Let's look at another binding file. Can we just pick a random one? Here's foundation. Do they have a binding? We've got service extension callbacks. Binding base. So binding looks important, I guess. So we'll take a look at some of the binding stuff, but maybe not with scheduler first, or rather, let's look at other non-binding scheduler stuff first. I mean, and we have ticker. Let's look at ticker. Okay. We have a ticker callback, which is a signature for the callback passed to the ticker class's constructor. The argument is the time that the object had spent enabled so far at the time of the callback being called. Okay, so ticker callback is a function of a duration. And I guess that when the callback is called, whatever is maybe the ticker object, whatever is calling the callback passes in the elapsed time is what this is saying. Here's the ticker provider. With an interface implemented by classes that can vend ticker objects. Tickers can be used by any object that wants to be notified whenever frame triggers, but are most commonly used indirectly via an animation controller. Oh, via an animation controller. Animation controllers need a ticker provider to obtain their ticker. Okay? If you want a ticker, you need the ticker provider. And if you are creating an animation controller from a state, then you can use the ticker provider's state mixin and single ticker provider state mixin classes to obtain a suitable ticker provider. The widget test framework widget tester object can be used as a ticker provider in the context of tests. In other contexts, you will have to either pass a ticker provider from a high level, for example, indirectly from a state that mixes with a ticker provider mixin, or create a custom ticker provider subclass. Okay, so you can create a ticker with a ticker provider. So I'm not sure entirely what's going on, but animation controllers, I guess they need a ticker for the animation ticks. And you can use these mixins. And there's also the widget tester thing. And these are, I guess these are different things that know how to make different sorts of tickers. Okay, and so what is a ticker? A ticker, so the class ticker, look at this comment, creates a ticker that will call the provided callback once per frame while running. Okay, and so you create the ticker and you pass it in an on-tick callback. And we've got some future for the ticker. And I guess we can silence the ticker. It's got this muted variable to keep track of whether it's been silenced. When set it's true, silences the ticker so that it is no longer ticking. Isn't that stopped? I feel like, okay. If the tick is already scheduled, it will unschedule it. This will not unschedule the next frame though. Okay, so this will basically stop the ticker. I guess the clock is always running, but it will stop keeping track of the work it's supposed to do. And we'll try to unschedule stuff. I guess it won't keep track of the next frame. Maybe that's because the next frame is already pushed down somewhere that the ticker no longer has access to. And then we'll keep track of, we have is ticking. And we'll keep track of whether this has scheduled a call to call its callback on the next frame. Okay. And so let's actually look at the implementation. So we're going to check if future is null, in which case we're going to say we're not ticking. If we're muted, we're going to say we're not ticking. And then we're going to look at, otherwise, the future is non-null and we are not muted. And we'll check if the frames are enabled with the scheduler binding instance, in which case we return true. Or we look at the scheduler phase and check that it's not idle, in which case we return true. And then otherwise we return false. It says, for example, we might be in a warm-up frame or a forced frame. Okay, and then we can check whether time is elapsing for this ticker. It becomes true when start is called and false when stop is called. I don't know how that's different from mute. I don't know how stop is different from mute. Start starts the clock for this ticker. If the ticker is not muted, then this also starts calling the ticker's callback. Okay, so mute, a muted ticker is still started, but it's not calling callbacks. All right. And then stop calling this ticker's callback. If called with canceled argument set to false, the default, it causes the future returned by start to resolve. All right, so you pass in some future to resolve into. No, you don't pass in the future to start. Start returns a future. And I guess if you stop it, better stop here, then we're gonna resolve the future with a ticker canceled. And so that future is not going to do anything useful for you ever again. So calling this sets is active to false. Yeah, makes sense for stop. And this does nothing if called when the ticker is inactive. Okay, so stop, if it's inactive, it does nothing. We're going to take the future. I guess bang might be asserting that it's not null. Then we're going to set the future, the underscore future to null, the start time to null, assert that we're not active, unschedule a tick, and if we're canceled, we're going to cancel the future. Otherwise, we're going to call complete on the future. Cool. Is there anything else we should look at here, I guess? Here's an underscore tick that, okay, so underscore tick, maybe this is called in a loop every time we tick. It's going to take a timestamp, do some asserts about whether we're ticking as scheduled. We'll set animation ID to null. I'm not sure why. Maybe because we're done animating whatever we were animating before. Question mark equals. This I don't know exactly what's going on. Something about comparing the start time to the timestamp, I assume. Then we're going to call on tick, the callback. on timestamp minus start time exclamation mark. And then we'll check if we should schedule tick. Let's actually look up Dart exclamation mark. Maybe also quotation mark. Maybe just Dart syntax. Here's a cheat sheet. MSA says that double question mark equals is a sign if variable is null. A sign if variable is null. But is it only if the variable is null? Like if the variable is not null, does it do nothing? Okay, here we go. Dealing with null. If b is null, assign the value of val to b. Otherwise, b stays the same. Okay. So MSA says, yep, you can check more on Dart docs about null safety. Okay, that's where we are. I think we're at the Dart null safety doc. So if b is null, assign the value of v to b. Otherwise, b stays the same. Okay. There's exclamation mark null safety. Let's see. Instance of. Is it some sort of instance of thing? What does the exclamation mark mean before, mean after a chunk callback? Is a new Dart operator for conversion from a nullable to a non-nullable type. Okay, so this is yeah, this is I think the same kind of thing in Kotlin, forced null safety. Okay, great. Thank you, MSA. Throw of value is null. All right, great. All right, cool. And then schedule tick is the scheduler binding stuff. So I guess let's look at scheduler binding next. Dispose. Release the sources used by this object. Okay, let's look at scheduler binding. I do that here? Yeah. All right, so we've got some callback stuff, some kind of opening stuff that looks not essential, I guess, in the top. We've got this underscore task entry, which is, I guess, like a private task entry class, I guess, parameterized by T. Signature for the scheduler binding scheduling strategy callback, called whenever the system needs to decide whether a task at a given priority needs to be run. Return true if a task with a given priority should be executed at this time, or false otherwise. Oh wait, no, that's scheduling strategy. That's not what I want. Task entry is just, you give it some task, some priority, a debug label, and whatever a flow is, this.flow. And we'll assert some stuff. And we've got a task callback that we're going to keep track of, a priority. And I guess we're going to keep track of all this stuff in here. Where did the import flow? Okay, dart.developer as flow. That may be important. We've got a frame callback entry, which takes a callback. Okay, and some stuff about what we're rescheduling. And a frame callback. I don't think we've seen frames yet, have we? We've got an enum for scheduler phase. The various phases that a scheduler binding, or I guess at least for the scheduler binding, that the scheduler binding goes through during handle begin frame. This is exposed by scheduler binding.schedule phase. The values of this enum are ordered in the same order as the phases occur, so their relative index values can be compared to each other. Okay. We start idle, and then we've got some transient callbacks. Typically, these callbacks handle updating objects to new animation states. Okay, so I guess mainly animation stuff. Then we have mid-frame microtasks. These are microtasks scheduled during the processing of a transient callback. So I guess, are they scheduled, like, does the transient callback create a microtask? This may include, for instance, callbacks from futures resolved during the transient callbacks phase. Okay, so I guess it's, you might have some futures that happen to resolve at this point. And then we have persistent callbacks scheduled by add persistent frame callback are currently executing. Yeah, okay. So all right, when we're in the persistent callbacks phase, and then we're currently executing persistent callbacks, as you might imagine. And then we have the post frame callbacks. So I guess after the frame is done, we've got some post frame callbacks, and that's the end of a frame. And then we start all over. I guess you go idle. No frame is being processed. Cool. And then there's some stuff about performing callback cleanup. Use a scheduler for running some stuff, including transient callbacks, persistent callbacks, post frame callbacks, and non-rendering tasks to be run in each frame. These are given a priority and executed in priority order according to scheduling strategy. And what is it? It's a mix-in on binding phase. And it's got a function to init instances. And I guess we can add timing callback if we're not in the release mode. Or is this still in the mix-in down here? Or does this close off the mix-in? 1, 2, 3. I think this is still in the mix-in. We can get some stuff. We have a list of timing callbacks, but it's a list. Okay. And we can add a timing callback, and it's just going to put it at the end of the list, I assume. We're going to check if the timing callback length is 1, and in which case we're going to assert some stuff and call the platform dispatcher and set on report timings to execute timings callbacks. Not sure why. Then we're going to assert some stuff. Maybe we should read this comment. Add a timing callback that receives frame timing sent from the engine. This API enables applications to monitor their graphics performance. Okay, so this is, I guess, mainly for monitoring their graphics performance. So you get a callback, and that's why, where is it? We look for something that sounded debugging, wasn't it? I'm not sure. At any rate, so this is for reporting callbacks for monitoring. So I'm going to ignore it. We can execute timing callbacks, and we've got some cloned callbacks. So I guess we make kind of like an immutable clone of whatever the current callbacks are, and it's final, which is not surprising. And then we're going to try to execute the callback and catch some stuff. If timing callbacks contains callback, then we're going to call callback. But wasn't timings callbacks a list? So is this a linear search for the thing we passed in? Let's find that out. Oh, well, it's passed in here. So yeah. So I guess the idea is either Dart is has some sort of fancy list with a quick contains operation, like they might, like under the hood, be using some sort of set contains, or our list is so small that a linear search is efficient, and that sometimes is the case. So I'm not sure which regime we're in, but just something maybe to note. Or maybe it just doesn't have to be fast for some reason. I don't know. We've got something that keeps track of whether the application is visible, and if so, whether it's currently interactive. That I'm sure is used by like a lot of the mobile devices. We've got some sort of callback for when the application lifecycle state changes, and we look if it's app lifecycle state resumed or inactive. We call set frames enabled state to true. Otherwise, if it's paused or detached, we call set frames enabled state false. Yeah, I'm guessing this is mainly for things like iOS and Android. Like when you move another app into the foreground or whatever. And then we have a scheduling strategy, which is the strategy to use when deciding whether to run our task or not. I wonder what the definition of that is. I'm not sure. Here's the future for schedule task. Schedules a given task with a given priority. If a task returns a future, the future returned by scheduled task will complete after the former future has been scheduled to completion. Okay. Otherwise, the return future for scheduled task will complete with the same value returned by task after it's been scheduled. Okay, so we give it a task and a priority and some debug stuff and maybe a flow. We check if we're the first task and record it. And then we create, I guess, a task entry object and we add it to the task queue. I don't think we've seen the task queue yet, have we? And then we've got this function to run tasks. And is this small? This is small. Scheduled by ensure event loop callback. Doesn't seem to do much. Handle event loop callback. Is this the main event loop? Execute the highest priority task. If it is a high enough priority, returns true if a task was executed. And there are other tasks remaining, even if they're not high enough priority. Returns false if no task was executed, which can occur if there are no tasks scheduled, if the scheduler is locked, or if the highest priority task is too low a priority given the current scheduling strategy. Also returns false if there are no tasks remaining. Okay, so this seems like an important part of the event loop, maybe the main event loop for scheduling. This is I guess this returns bool, which we just saw in the comment. And if our task queue is empty or it's locked, we just quit, return false. Otherwise, we get the task queue first, presumably the first item on the task queue, and we make it task entry dynamic. Maybe that means dynamic type. And we look at the scheduling strategy, and we pass in the priority, and this is the binder, right? I think since we're in the binding class, or unless we're in another class that I'm not sure. Then we're going to try to, maybe first is like peak, because then we're going to call task queue remove first and entry.run. So whatever the task is, it knows how to run itself. And then we're going to catch some stuff. And then we're going to return whether the task queue is non-empty. And then if none of that if statements catch, then we're just going to return false. This is kind of the fall through condition. Okay, I'm curious what kind of type the task queue is. I'm guessing it's just a queue. A heap priority queue. A heap priority queue. Does that mean, I can't remember if heap is min queue or max queue, just out of curiosity. Let's see if Wikipedia knows. Oh, it's a heap. So, okay. While priority queues are implemented using heaps, they are conceptually distinct from heaps. A priority queue is an abstract data structure like a list or map. Just the list can be implemented with linked list or array. Yeah. Okay, so yeah, right. Okay, this makes sense. This it could be a max heap or a min heap. So it doesn't tell us, but it's some heap, and that implements a priority queue. And the heap here is just telling us an implementation detail about the queue, which will tell us some of the performance characteristic of the abstract types. All right, so that's really interesting. I think that's pretty much the going to be the fundamental scheduler thingy. What I want to look at next is, let's see. I wanted to see what something was. What was that thing? The flow. I want to take a look at, see if I can find the flow. And George Bass is asking, could you suggest a way to make ChatGPT or GPT-4 do the job of reviewing large code spaces like Wireshark? It has a token limit. I cannot. So ChatGPT does not have an API where you can train it on new stuff. GPT, I thought that I haven't used it. I thought the API was basically you train it on request response pairs. I'm sure people have all sorts of kind of hacks to try to get it to have like request response pairs that try to train it to try to train it as if you were training some other kind of learning system. But I no, I don't know. I think the token limit is a problem, and also you're gonna. I mean, it's like a generative system. So I think of these things as basically like just ordinary search engines. It more or less is mostly going to repeat back what it's seen. It can do some summarization stuff, but my sense is that like ChatGPT and GPT-4 are not the right tools for that sort of task. I don't know what is the right tool, but you can imagine some combination of something like a static analyzer that understands the structure of the code, maybe combined with one of these generative model things. You could get something. Maybe that's essentially what things like the GitHub code thing. I'm forgetting the name, but they have these systems for trying to like suggest to you what the next thing you should write in code is. You could probably combine a few of those sorts of things and ask it to summarize code. Or really the sort of thing that we're doing on this show is we're reading a bunch of stuff and kind of like getting a feel for it. So you would probably want to train a model ultimately on that sort of data. But that being said, I'm sure there are people who like live and breathe machine learning stuff who would have intuitions about things to try that are, there's all sorts of like hacks or things that people know will work just based on experience, even if you think in theory it shouldn't work. But I don't, So I mean, if anyone is watching this and they have an idea for how to do that sort of thing, I'd be curious to know as well. GitHub Copilot, yeah, thank you. GitHub Copilot is the thing I was thinking of, which I think maybe was trained on some version of GPT. I'm not really sure. But yeah, I mean, so occasionally I will ask ChatGPT about something about a code base. And if the code base is like old enough where it's been discussed on the internet, it will sometimes know things. Like, sometimes you'll ask it, like, what does this variable mean in this code base? And ChatGPT will have something sensible to say. So it's not outside the realm of possibility. But my guess is that, like, if you wanted to do that, what I would recommend, and basically somebody has asked me a similar question in real life. And the answer I gave to them essentially is that what I would use is I would pick one of the cloud providers and use their like enterprise machine learning tools and trade it on databases. And you'd probably have to like write your own summaries. But I would use something that's more set up for letting you train on your own data. Okay. So let's get out of schedule. Let's see if we can find flow. I think it was in developer. Is that here? Let's see if these files seem small, so maybe GitHub will return something something useful. We have source rendering flow. Let's look at that. Here we are in lib source rendering flow. Is this where we get the definition of flow? We don't seem to import flow. We import foundation. Let's see if we find a capital F flow. Just do. We have flow painting context. We have a flow delegate. What would it be like a class flow base? So this is promising, but I don't think it's quite where I want. I think we already looked at ticker, right? Looked at lots of ticker stuff for sure. Will GitHub let me search like this? I don't think it will. No. Let's see if I've already... oh, now. I'll clone this and use other things. Receiving objects, resolving deltas. So now we know what this means. We're receiving, I guess, the object database, and then we've got some deltas to resolve. So what do I decide? I guess class, maybe like class flow space, something like that in Flutter. There you go. Basic. Widget's basic. It's a basic widget. Okay, so where is that? Flutter lib source widgets, yeah. Is it in basic? Okay, so here's class flow, and it's going to extend a multi-child render object widget. Okay, a widget that sizes and positions children efficiently according to the logic in a flow delegate. Flow layouts are optimized for repositioning children using transformation matrices. All right, cool. The flow container is sized independently from the children by the flow delegate get size function of the delegate. The children are then sized independently given the constraints from the flow delegate get constraints for child function. Rather than positioning the children during the layout, the children are positioned positioned using transformation matrices during the paint phase using the matrices in the flow delegate paint children function. The children can be repositioned efficiently by only repainting the flow, which happens without the children being laid out again. Contrast this with a stack, which does the sizing and positioning together during layout. The most efficient way to trigger a repaint of the flow is to supply an animation to the constructor of the flow delegate. The flow will listen to this animation and repaint whenever the animation ticks, avoiding both the build and layout phases of the pipeline. So, oh, thanks, Raxnef. I didn't see this until just now. I don't think that we're going to look at flow. So flow is interesting. I think, well, it did the thing it just said, which is it's got some transformation matrices. And I think this should be for things like, resizable screens and like maybe reactive layout. Is that the sort of thing people talk about? Which is interesting. I'm kind of more curious, at least on an initial pass through, at looking at the layer beneath this sort of thing. So maybe we'll look at some of the base widgets, but I feel like looking maybe at the painting stuff first before something like flow makes sense. And then George Bass is saying, GPT-4 is very accurate, but I have to ask it every 2 minutes because of the token limit. Now I'm using GPT-4 extension in VS Code. It does the job faster. Thank you. Yeah, sure. I haven't used GPT-4. I think the thing I'm using is GPT-3, right? Which I would not describe as very accurate. Or ChatGPT. And what I've heard on the internet is that like whatever Bing is using for chat, which I thought was ChatGPT-4 under the hood, has been it like refuses to answer a bunch of stuff because it's like very scared of making a mistake. But I would imagine that GPT-4, the more direct model, would be more accurate. What I don't know is like the generative models have no understanding of the structure of the universe, right? They'll like talk to you, but they're more or less things are just kind of understood at the linguistic level. So if you're looking at something that nobody's really like looked at or thought about before, I would expect the models to continue to have to be able to provide limited insight to those sorts of things. But we'll see. I think it remains to be seen. Yeah. Okay. So let's take a look maybe at some of the painting stuff, and just in the interest of trying to keep these these episodes not too long, I think I might stop after the painting stuff, and then as I mentioned before, eventually we're going to get into a regime where we're diving deeper into code bases using something like iterative deepening, where we do one pass through, we take some time away from the repo to like let our brain chomp on the various things that we've learned, and then we come back and kind of go a layer deeper. So in order to make that work and also make sure that people are getting their requests filled, kind of the direction I'm heading is the as I mentioned, I think last week, having the fan requests, making sure that we're getting through them in like a fan request Friday format, and then other days of the week, I might move away eventually from kind of these theme days and kind of move more toward a thing where like once we're doing live coding and we've settled on a stack, kind of really getting to know that stack super well. And that stack will presumably go from the kernel up to whatever cloud stuff we're using. And so we'll just kind of like go up and down like that. So I think that's the direction that this is heading. I'll let you know. I try to talk through all this stuff. And if people have feedback, I always consider it. Okay. So here's source rendering. But I thought painting was maybe in another folder. So let's double check this before we go too deep on rendering. Here's foundation. Did we like foundation? Isolates is like a Dart thing. I think in this, they said this folder was more Dart heavy. Stack frame might be important, but I'm not sure. Let's see if we can find painting. Yeah, we have painting in physics. All right. So how are we going to do this? Rendering, we have things like box. We have the binding thing. Flex. Maybe flex layout is what I was thinking of instead of flow. Maybe I was confusing flow and flex. I'm not sure we're going to figure that out this episode though. Selection. Not sure if that's like a thing that's being selected on screen. A sliver. A table. A view, and wrap. Queens should be for animations. Texture should be for textures. Performance overlay, I guess that's for maybe visualizing performance. Maybe look at layer and box and binding. So let's do that for painting. And then for physics, gravity simulation, spring simulation, and clamp simulation. Okay, these are mildly interesting, but we're going to look at more physicsy stuff, and I'm going to guess that this is maybe not the best use of our time. And then, wait, this is rendering. Where's painting? Let's open painting here. Network image. Basic types. I guess let's look at basic types. Beveled rectangle border. Let's look at binding. Border radius. I'm not sure. Clip. Edge insets, geometry. I think that this is looking mostly like stuff that's going to be similar for any painting library. I'm looking more for stuff that is maybe Dart specific, or rather Flutter specific, and it's going to tell us things about how Flutter in particular works. So I'm going to skip a lot of stuff. Maybe I'll look at geometry, and then I'll start at the end here. Okay. Where did my tabs go? Don't I have a bunch more than this? What? What's going on here? Not sure. Well, I can close all these. I can close ticker. Here's stack frame. I feel like I'm missing a bunch of stuff. Let me try opening this in a new window and reopening the paint stuff here. Okay, so we're going to look at painting, then we're going to look at rendering, and then we're going to call it a day. Okay, so binding, maybe alignment and basic types. Flutter logo, I don't think we need to look at. I don't know what a stadium border is. Maybe text painter, just in case that's there's something settled there. And I guess let's look at box border. We'll just look very quickly at box border. We've got some box name, box shape enum, which can either be a rectangle or a circle. I guess there can be circular boxes in this world. And we've got a base class that's going to extend a shape border. And let's just look at some of the things you can do. You can add another shape border to it. I'm not sure what that does. We have is uniform, whether all four sides of the border are identical. They're usually more efficient to paint. Is this different from being regular in the polygonal sense? Seems like the same as regular. We can linearly interpolate between two borders. That's what lerp is. If a border is null, it's treated as having four border side none borders. This supports interpolating between border and border directional objects. If both objects are different types, but have sides on one or both of the lateral edges, then the sides are interpolated by reducing A's lateral edges to border side none over the first half. Okay. I'm not sure about all that stuff about none, but I mean, we'll take a quick look. So we might so we'll do this check, and if so, we're going to just call border.lerp instead of box border. If A and B are both type border, I guess. And then we'll have call maybe border directionals lerp. Otherwise, you have this case for if one is a border and the other is a directional border, and so on. I'm not sure what the base case is, but maybe this is the base. So we're going to call border directional of calling lerp on all the sides. So I guess interpolate all the sides with some sort of scaling or monkeying around so things work correctly. We can get an outer path by given a rectangle and something about a text direction. I'm going to return path.addRect. And we have a paint function, which takes a canvas, a rect. What is the rect? Paints the border within the given rect on the given canvas. Okay, so we're going to give it a canvas and a rectangle, and it's going to paint on the rectangle. This is an extension of the shape border.paint method. Okay, and so what does it do? Nothing. What? Text direction is direction. The box shape is box shape rectangle, and border radius is border radius. So maybe this is just somehow calling out to the thing that we're extending, shape border paint method. It allows a box border borders to be applied to different box shapes and different border radius parameters without changing the box border object itself. Okay. And we can also paint uniform border with radius. Okay. And we've got a border which extends a box border. You would think a box border extended border, but for them, it's the other way around. All right, cool. It just gives us a little bit of a snippet about what's going on with some of the painting stuff. So here's painting binding. I'm just looking at this because other binding things have been, they've contained some stuff about the kind of like Flutter algorithm. So I'm wondering if there's more like layout algorithms type stuff in this binding. Here's a binding for the painting library. Hooks into the cache eviction logic to clear the image cache. Requires the services binding to be mixed in earlier. Okay. All right, so so shader warmup. So the shader warmup instance to be executed during init instances. Defaults to null. If the application has scenes that require the compilation of complex shaders, it may cause jank in the middle of an animation or interaction. In that case, setting shader warmup to a custom shader warmup before creating the binding may help if that object paints the difficult scene in its warmup canvas. This allows Flutter to precompile and cache the required shaders during the startup. Okay, so we've got this notion of a warmup canvas. And this is basically just going to put stuff into cache, I guess, so that it doesn't cause like jank artifacts when you call it for real, which is interesting. You can create an image cache. Here's some deprecated method that we'll ignore. Here's an initiate image codec from buffer. I'm not sure what the codec is here. So it doesn't seem to be doing it. It seems to mostly be calling out to another function. You can evict, I guess, something from the binding. I guess evict an asset. We got some stuff about system fonts. A listenable that notifies when the available fonts on the system have changed. System fonts can change when the system installs or removes a new font. To correctly reflect the change, it is important to relay out text-related widgets when this happens. When the available fonts have changed. I'm not sure why this doesn't just call when... seems like you only want to repaint when the actual font used in the app changes, rather than when the system fonts change, but I think that this is maybe part of figuring out when that happens as well. We've got some sort of handler for a system message. And that's about it. Okay. And then we have the singleton that implements the Flutter framework's image cache. The cache is used internally by image provider and should generally not be accessed directly. So I'm guessing this is images in the sense of like when you have a picture, like a picture or a logo or whatever to display in your app. Here's alignment. It allows text direction aware resolution. A property or argument of this type accepts classes created either with alignment or its variants. We've got some alignment geometry. We can sum two alignment geometry objects, which I guess is summing their x's, their starts, and their y's, and returning a mixed alignment object. Operator minus returns the negation of the object. Okay. And then we've got this, what is linear interpolation method again. Okay. Resolve. Convert this instance to an alignment, which uses literal coordinates, the x coordinate being explicitly a distance from the left. Convert to string. More alignment stuff. So I'm not sure exactly what's going on, but it seems like because of kind of like the maybe recursive or nested nature of some of the stuff, I think one of the things that's going on is like, you know, well, I'm not sure if you know, but one of the things that happens in Flutter is constraints are passed. I guess you have to pass the constraints down from the top, because ultimately the first constraint is known by like the screen size. And then as you render stuff, the constraints get narrower and narrower. And so I'm imagining somewhere along the line, what's going on is that a parent is telling its child to like draw itself on some canvas, and the child just draws itself as if that canvas were its whole world. But then it's the parent's object to kind of patch together those canvases in a way that makes sense. Let's verify this thing about constraints that I just said. Yeah, constraints go down, sizes go up, parent sets position. That's basically what I just said, but said much more nicer. Yeah, so I guess parents pass down their constraints. The children have to tell them sizes. I guess the children just tell you what size you're going to occupy. Like, given this constraint, I guess I want to be this many pixels big. Then the parent is going to figure out where to put you. I'm not sure who actually does the drawing, though. I was thinking the children draw themselves, but maybe that's not the case. So somewhere in this alignment stuff, so like sometimes, I'm not sure if we can see, you see like addition, like things are being added and subtracted to other things. And I'm guessing that some of that logic is about doing things like adjusting the canvas size for the fact that, like, as we're passing it to the child, we might be pretending that that the canvas is this big. But then as we're pulling things back up to the higher levels, we're having to recompute stuff to figure out where actually that bit of canvas is in the larger ambient space. Something like that. Here's Text Painter. We've got things like an enum about whether to clip or fade the overflowing text or to use an ellipsis. And I guess render overflowing text outside this container is an option. You can just stomp on whatever is supposed to be outside the container. We've got some stuff for holding dimensions. Okay, text boundaries. Okay, I'm just going to go through this quickly. Here is the rendering binder. I don't think we've looked at this yet. The glue between the render tree and the Flutter engine. This looks pretty promising. So the render tree should be, I assume by render tree, it means this thing that has parents and children that we just talked about. We've got a pipeline. A pipeline owner. So a pipeline owner knows whether you need a visual update. And it knows about like semantics owner and stuff about semantics updates. We have a platform dispatcher, which I'm going to assume is a platform specific way to dispatch things from the pipeline. We can initialize the render view. We've got some sort of mouse tracker, and we've got this persistent frame callback stuff that we saw before. All right, let's see if we can scroll through and see anything. Lots of service extension stuff. Init render view creates a render view object to be the root of the render object rendering tree. Okay, so the render view is the root of the tree and initializes it so that it will be rendered when the next frame is requested. So I don't think we're re-rendering everything on the screen. So I guess the rendering tree might just be the stuff that needs to be rendered, or maybe we are re-rendering the whole screen. I don't know. We're going to create a render view from a configuration and a window. Then we're going to prepare the initial frame. And that's all we're doing. To init. We've got some sort of platform brightness callback, some event dispatcher, override from gesture binding. We're going to dispatch a pointer event in this particular case, something about hit test results. And if there's no mouse tracker, or no, I guess must assert that the mouse tracker is non-null and call update with event. And then we're going to call super dispatch event. What is super? I don't know. We have a class. I'm not sure if this is the class we were looking at, but I guess it might be binding base. Or no. It must be that mixin we were looking at. The dispatch. Super might be something in the mix in, I guess. But I'm not going to look too carefully. And we've got some handlers. And this function that we'll call a getter, send frames to engine. Whether frames, okay, this is just a getter, I guess, for some bool property. All right, I guess let's take a look at it anyway. Whether frames produced by draw frame are sent to the engine. If false, the framework will do all the work to produce a frame. Okay, so I guess we can have an engine do the drawing for us, but we can also have the framework, maybe by which it means Flutter, do the drawing. So possibly this means like we can either like send it to Android or iOS or the browser or whatever to actually handle the drawing. And if that's not good, for whatever reason we decide not to do that, then maybe we'll manually draw stuff in Flutter or something. And here's draw frame. Pump the rendering pipeline to generate a frame. This method is called by handle draw frame, which itself is called automatically by the engine when it is time to lay out and paint a frame. Each frame consists of the following phases: the animation phase, microtasks, and the layout phase. And then we have a compositing bits phase, and a paint phase, and a compositing phase, and this semantics phase, and then a finalization phase. Okay. This is a really important method. The first thing that happens is animations. And then microtasks, which we saw microtasks before, says this typically includes callbacks for features from ticker and animation controllers that completed this frame. And the layout is all the dirty render objects in the system are laid out. And we can see render object.perform layout, which I guess we should take a look at. And render object.mark needs layout for further details on marking an object dirty for layout. So yeah, marking stuff is dirty, so it needs to be laid out again. Compositing, I guess we'll composite any dirty render objects that needs updating. In the paint phase, all the render objects in the system are repainted. Everything in the system, not just the dirty ones, I guess. Oh, no, sorry. I missed this word. All the dirty render objects in the system are repainted. This generates the layer tree. Cool. So then this is going to generate the layers. And we can see this for further details. And then compositing, the layer tree is turned into a scene and sent to the GPU. So in the compositing phase, I guess we'll do things like, I don't know if this is stuff like maybe, this image is partially occluding this other image. So we only need to draw part of that occluded image or whatever. And then the GPU will just draw the relevant stuff. And then in the semantics phase, all the dirty render objects in the system have their semantics updated. And I guess this is the thing that calls back for assisted technology. And then we have some sort of finalization phase. After draw frame returns, handle draw frame then invokes post frame callbacks, registered with the add post frame callback. And then draw frame is really not going to do much. It's going to call PipelineOwner to flush the layout. Then we're going to flush compositing bits. Then we're going to flush paint. And then if we're sending frames to the engine, we're going to call the render view composite frame, and then PipelineOwner flush semantics. And then first frame sent is set to true. Cool. Composite frame sends the bits to the CPU, to the GPU. Okay. Cool. So I guess the next question is, what's the pipeline owner? And I want to see a bunch of this, like render object perform layout, I think is what I really want to see. Let's grab this string. Let's see if we can figure out where the pipeline owner came from. The pipeline owner doesn't seem to be something we've explicitly imported, but what else do we have? Foundation, gesture, semantics, services. Maybe foundation? Okay. See if we can find the definition of pipeline owner. Got a PipelineOwner tree test. Yeah, we've got some tests. Can I skip the tests? I'm going to ignore a stack frame and see if there's anything about pipelines in here. We have platform. What about in source renderer? Okay, what about on here? Maybe class rendering object. Okay. So I'm going to get rid of layer and box and basic types, I think. Did I get rid of basic types? Yeah, it's mildly interesting. I guess we'll keep it at the end. We got rendering object. And the other thing I wanted was whatever this string is. Render object perform layout. Do we think it's the layout builder or an object? Let's see if it's in the object. What's it called? Perform layout. Okay, so this seems to be maybe something that each object, I guess, overrides, provides its own perform layout implementation. So let's take a look at render object. And this will be the last thing I think I look closely at. All right, so we've got some foundation stuff that we're exporting. That doesn't look so exciting. We've got parent data, a base class for data associated with a render object by its parent. So its parent is associating the metadata with this object. It's called parent data, but it's not data about your parent. I guess it's data about your children. Some render objects wish to store data on their children, yeah, such as the children's input parameters to the parent's layout algorithm. So I guess the parent can store, your parents know some stuff about you, and that's how that happens. We've got some painting context callback, a place to paint, which is, I guess, a painting context. Rather than holding a canvas directly, render objects paint using a painting context. The painting context has a canvas which receives the individual draw operations and also has functions for painting child render objects. When painting a child render object, the canvas held by the painting context can change because the draw operations issued before and after painting the child might be recorded in separate compositing layers. For this reason, do not hold a reference to the canvas across operations that might paint child render objects. Wait, what? When painting a child render object, the canvas held by the painting context can change because the draw operations issued before and after painting the child might be recorded. Recorded, I don't know what that means in a separate compositing layer. It sounds like our children don't hold a reference to the canvas across operations that might paint child render objects. But I thought this was telling us that we should hold a reference to it. It also has functions for painting child render objects. Okay. These are just functions. And this is about holding a reference to the canvas. And then here's the class. And George is asking, do I have any experience with exploit development in cybersecurity field? And what's my opinion on today's CVEs/databases? Because some of these exploits really help out. I do not. I was on the other side of security, so like defending things. Are you asking about CVEs for databases in general? I don't really know the answer either way. I would expect that. I mean, there are a lot of databases out there. There's a lot of misconfiguration out there. So, but I don't have any actual, I guess, domain expertise about like database CVEs. Okay, so back to painting context, like exploit DB. Oh, like I see. That's what you mean by yeah. I think I'm not sure. I don't know about exploit DB in particular. Um, but there are professionals who do this sort of thing and use those sorts of tools. And if all of those exploits were patched everywhere, then that wouldn't be a career that they had. So just by general principles, I think we have to infer that there are always vulnerabilities, and some of them are known. I don't know how exciting some of them would be. Like if you want to break into Fort Knox, that's a lot harder than if you want to break into, you know, the milkshake stand at a like local football park, something that has lower security, right? So, so there's actually tons of people who do like live streams of exploit stuff. I don't really know anything about it, so I would recommend checking them out. But certainly there are exploits that can be exploited and if there weren't, we also wouldn't have all of this stuff where major corporations are like leaking their data every couple of months. There's like a new one, like LastPass, I think was pretty recently. I don't know whether that was using these kind of exploits, but some sort of exploits, and some combination of usually like social engineering and then exploits that are like perhaps tuned to the particular environment. Yeah, I don't know if that's the best I got. I'm sure that's not a great answer to your question though. And then Racksnap is saying a lot of exploits are patched in the latest version, but a lot of software still contains not only the latest version of stuff. Yeah, that's also true. And if everyone's behaving well, then if you're a researcher and you discover a vulnerability in like the latest version of a piece of software, then you're supposed to disclose that to the people developing the software so that they can fix it before the exploit becomes public knowledge. But of course, there are people who employ researchers of this sort who are not on the up and up, and I won't go into any more about that. But yeah, so. But Racksnap is right. In theory, most of this stuff shouldn't exist, and a lot of the vulnerabilities happen in environments that either A, are running old software like Racksnap is saying, or B, just kind of not following best practices. Like they might have things locked down, but they've committed their private keys to GitHub or something. There's all sorts of ways that you can make errors in locking things down. Yeah. Okay. So here's the painting context thing. We can create one. That's not so exciting. We can get estimated bounds, an estimate of the bounds. The canvas will allow painting outside these bounds. The canvas will allow painting outside the bounds. Okay. We can repaint the given render object by calling repaint composited child. We give it the child. The render object must be attached to a pipeline owner, must have a composited layer, and must be in need of painting. Here's another, I guess, repaint composited child. Oh, this is like the underscore. Maybe this is the implementation. Yeah. And we've got some sort of offset layer. So this might be some of the offset stuff I was kind of talking about before. And I guess we check if the child layer is null. And we call child update composited layer on the old layer, not using the layer setter because the setter asserts that we not replace the layer for repaint boundaries. That assertion does not apply here because this is exactly the place designed to create a layer for repainting boundaries. Okay, some kind of like fiddly details. What is this if statement? So if the child layer is null, then we do some stuff. Otherwise, it's non-null, and we get some offset stuff. We remove all the children for some reason, and we call update composited layer on the child layer. I guess like kind of, this isn't literally recursively, but we're now doing stuff with children in a way that deals with compositing. And so that's kind of like flowing down the graph. We'll check if the updated layer and the child layer are identical, in which case we've done redundant work, right? Create a new layer instead of reusing the existing layer. The documentation, blah, 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 for more information about how to correctly implement this method. So it's telling you that you've messed up for here, I guess. And then we're going to assert that the debug old offset is equal to updated layer offset. And then we're going to call child, we're going to set child needs composited layer update false because we've just done the thing. So we don't need to do it again. We're going to check for some more stuff is identical. We're going to check that the child layer and the child layer handler layer are identical, are the same thing. And assert some more stuff. And then in a null safety way, I guess if the painting context is null of the child layer and its paint bounds, we're going to nullify the child context on the left-hand side. And then we're going to call child paint with context on child context and a 0 offset. And then we're going to double check that the paint method did not replace the layer. The first check is done. Okay. And then we're going to call child context stop recording if needed. Okay, I think this is a pretty fundamental painting routine. So the child must have been composited. I guess that's what's this composited is here for, but we are repainting it and not compositing it. We could also update the composited layer of child without repainting its children. And update the composited layer of a child without repainting its children. Okay. The render object must be, okay, so it's got to have some PipelineOwner that's attached to. All right. So now, okay, so we can paint a child render object. If the child has its own composited layer, the child will be composited into the layer subtree associated with this painting context. Otherwise, the child will be painted into the current picture layer for this context. The paint child is going to take a render object as a child as a render object and some offset. We'll check if the child needs its boundary repainted, and if so, I guess presumably repaint the boundary. Okay, so we might stop recording if if it needs its boundary painting, we might stop recording, and then we're going to call composite child. Otherwise, we'll check if the child was repaint boundary. If a render object was a repaint boundary, but no longer is one, this is where the framework managed layer is automatically disposed. Okay, so maybe we used to be a repaint boundary. We'll set the layer handle to null, and we'll call child paint with context. Otherwise, those two other things are false, and we're just calling child paint with context on this in the offset. Cool. Can we find paint with context? Because that's going to be the thing that seems like it's doing kind of the adjustment for, as constraints are going down. So here's paint with context, or at least one implementation of it. I'm going to take a context and an offset. Some debug stuff. I'm going to ignore the debug stuff. We'll check if we needed a layout. If we still need layout, then that means that we were skipped in the layout phase and therefore don't need painting. You may not know why that is yet. All right. So we're checking if we're in release mode and some debug stuff. Oh, sorry, if we're not in release mode. So if we're in like debug or developer mode, then some stuff will happen. And then I think this is where that if ends, and we have a big assert. It seems to maybe be doing, wait a minute. I'm not sure. So there's some assert thing. I'm not sure what parenthesis followed by like a function block is. That might be a lambda. So if we need compositing bits update, then we'll check out the parent as a render object, in which case we cast it as a render object. We say that we haven't been visited by our parent. So this is kind of like a standard like visited thingy in tree algorithms. Then we're going to call parent visit child on this thing. This does kind of look like a lambda. We're going to check if the child is us, in which case we'll set visited by parent to true. Let's check what a Flutter, what a Dart lambda looks like. Well, we've got this double arrow thing. I'm not sure. It seems like it's just passing in a function of a closure. Is that the thing I want? Anonymous enclosures. Can I find this? All right, I'm just going to assume it's some sort of lambda or anonymous function or whatever you want to call it. At any rate, we check if we're visited by, well, we're going to check if, I guess we're going to call visit children. And if the child we're visiting is us, we'll mark ourselves as visited. And if we haven't been visited by parent, we'll throw an error. And we might for some other error, and then we'll return true. And if we're down here, I don't know what's going on because I don't understand the syntax well enough. We got lots of parentheses and whatnot. Here's some stuff about debugging. And I guess we're going to set repaint, needs paint to false, needs composite layer to false, was repaint boundary to is repaint boundary. So I guess if we used to be repaint boundary and we're here, then we are still, yeah, I guess then, right. If we're here now, then in the past, we will have been a repaint boundary. And then we're going to try to call it with paint. We're going to try to call paint with context and offset. Okay, so it seems like maybe the thing that's ultimately called is paint. And what this function is doing is kind of setting up some stuff about kind of the tree walking object, the tree walking algorithm. You can find where the implementation of paint is. Void paint. So subclasses override paint. Okay. So when we call paint, it's the things that it's the objects themselves that know how to paint themselves. So like a box will know how to paint itself in the context. Maybe we can see what the definition of a painting context is. Did we see that? I think we might have seen that. Yeah. Class painting context extends clip context. And what sorts of stuff does it have? It's got the rectangle, it's got the estimated balance, the container layer. They can repaint its children and stuff. Okay. But it should have some sort of canvas. Yeah, it's got some kind of canvas. Okay. So I think that modulo kind of understanding exactly what's going on with the syntax, it seems like we've seen now the fundamental stuff that Dart is using to paint. It's the objects that have, it's the rendering / object class or file that has the logic for passing down, for like calling down to children and giving them a context to paint themselves in. And this is presumably where the constraints go down sort of mantra is made true. And we've also taken a look at the the scheduler and the priority. And we haven't fully understood all of that. I think we've understood it kind of reasonably enough for a 2-hour show. And we haven't really looked at all at the widgets, like the vast family of widgets, or like how widgets manage their state, which I think is one of the things that Flutter people are often very interested in. But I'm pretty sure that Flutter will be part of the stack that I'll be using. So I'll imagine we'll revisit Flutter a few more times. But at least this, I think, gives us a sense of, especially compared to React, how things are organized a little bit differently. Then Racksnef is asking to look at object.dart line 892. Sure. 892. Am I in the right object.dart? Or am I in? So here, 892 for me. Oh, 862. I can't. I guess I did an upside down 6. 862. I have a feeling I'm in the wrong thing. The pipeline owner, man. Oh, yeah, I see. Okay, so 876 is where the class is. Thank you. Yeah, okay, so here's the pipeline owner. I did want to see this. Thank you, Racksnef. The pipeline owner manages the rendering pipeline. The pipeline owner provides an interface for driving the rendering pipeline and stores the state about which render objects have requested to be visited in each stage of the pipeline. To flush the pipeline, call the following functions in order. I guess we call the functions, right? It's telling us this is a command. It's an imperative mood, I guess you might call it. And we're going to call flush layout, flush compositing bits, which we've seen before, flush paint, and flush semantics. The renderer binder holds the pipeline owner for the render objects that are visible on screen. Okay, so it's the binder that has, this. I think this binding language was used in Android as well, if you've done Android development. You can create other pipeline owners to manage off-screen objects, which can flush their pipelines independently of the on-screen render objects. Okay, that's kind of interesting. And then pipeline owners can be organized in a tree to manage multiple render trees, where each pipeline owner is responsible for one of the render trees. To build or modify the tree, call adopt child or drop child. Okay, so we can, I guess, add or remove children to like prune the tree or expand it or graft it. I think we've seen other people call it during each of the different flush phases described below. A pipeline owner will first perform the phase on the nodes it manages in its own render tree before calling the same flush method on its children. Okay, this is if you have a tree of rendered or pipeline owners, I guess. No assumption is made about the order in which the child pipeline owners are flushed. And a pipeline owner may also be attached to a pipeline manifold, which gives it access to platform functionality usually exposed by the bindings without tying it to a specific binding implementation. All pipeline owners in a given tree must be attached to the same pipeline manifold. This happens automatically during adopt child. Okay. We need on visual update. I think we've seen, did we see this? I remember these things. No, we just saw this being called, and these were being passed in. And we've got a few callbacks. Is it all callbacks? Request visual update. Calls all need visual update if all need visual update is null. We've got an abstract node. Is this for the pipeline tree? This object does not have to be a render object. I think this is for the render object tree, I guess. But it doesn't have to be a render object. We've got a Boolean about whether we should merge dirty nodes. So the current flush layout call should pause to incorporate the render objects in nodes needing layout into the current dirty list before continuing to process dirty relayout boundaries. Here's flush layout. Update the layout information on all dirty render objects. And if we're not in release mode, we'll do some stuff. But I'll assume we are in release mode. Where does this end? I think maybe here. And then we're going to try some stuff while nodes needing layout is non-empty. So we're going to keep some some list of, or some collection of things that need to be visited. This is just this is looking like a tree traversal, as you would expect it to be. And we'll get the dirty nodes, which we're setting to nodes needing layout, the thing that we are calling while on, I guess. And we're possibly converting it to a list, or possibly just making a copy of it. Then we're going to set nodes needing layout to the empty list. Then we're going to sort the dirty nodes using depth. So A is higher in the sort than B if A's wait. If A is bigger than B, then this is positive, which I think for sorting functions usually means that it's lower in the sort. So I guess shallowness is priority, which would be the normal way that you do things. And then we're just going to iterate over the dirty nodes now that we've sorted them. And we'll check if we need to merge them, in which case we'll set should merge dirty nodes to false, I guess, because we're going to merge them. And if we if nodes needing layout is not empty, then we're going to add all of the dirty nodes in this range and break. But didn't we just set nodes needing layout to the empty list? Maybe this check is because some other thread might have populated the list after we set it to empty. I'm not sure. And then if we're down here, then we're no longer concerned about whether to merge dirty nodes. And then we take the ith dirty node, and if it needs layout and its owner is this, I guess this pipeline, whatever, then we're going to call layout with resize on the node. And then we're doing that for all of the nodes that we're iterating through in sorted order. And then at the end, we're calling should merge. We're setting should merge dirty nodes to false. That is all, I think, straightforward. What do you call it? Like traversal, I think. But I had maybe one question, which was, we sorted it and we're doing this stuff. And yeah, I think that all makes sense. I thought there was like a variable where I didn't figure out whether it was getting used, but I'm not seeing it. Okay, and then after calling, after like walking down this tree and calling the layout, the layout without resize, then we're out of this for loop. And I guess we're going to say that we're doing, if we're debugging, we're going to say debug doing child layout is true. I'm not sure. That's interesting. And then we're going to iterate over the pipeline owner children. So we also have this tree of pipeline owners, and we're going to call flush layout on the children, but we haven't sorted them or anything. And so that's why it says that we provide no guarantees on the order in which it's called. And then finally, we're going to set should merge dirty nodes to false. And if we are in debug mode, we're going to keep track of, I guess, how long we spent doing this layout stuff with this flush layout. And I'm going to guess that the other flush things are basically the same stuff. So flush compositing bits. Let's just see if there's anything different. This doesn't look like a tree algorithm, at least not initially. We're going to call nodes need compositing bits update sort on with this sort function on depth. And then, oh, we are going to iterate over stuff and call update compositing bits. And then flush paint is presumably the same. So we get a sort function. We get this thing, dirty nodes dot dot sort. The same thing. I'm not sure what this dot dot stuff is. And then presumably we should call node dot something. Here's node dot skipped painting on layer. That's not what we want. If node needs paint and need blah, blah, blah. If node layer handle attached, assert node is repaint boundary. If node needs paint, painting context repaint composited child on node. Okay, we're not calling a function of the node this time. We're calling this this function painting context with the node passed in as an argument. All right, cool. Well, that I think we did all the stuff that I wanted to get to. We saw the tree walking algorithms. We saw the kind of tree data structures. We saw the scheduler. And those will be the main things for the performance characteristics of, like, you know, when you're making a framework, the thing that makes Flutter different from other frameworks is mostly this sort of stuff. There's also there's going to be a bit that's non-trivial about having the right abstractions to actually send stuff off to the different underlying platforms, like the Android and iOS and Mac OS and Windows and Fuchsia and all that stuff. I imagine that's a lot of hard work, but that's mostly going to be about having implementations for all of the different APIs. But this layer of the code that we've looked at today is really going to be the thing that makes Flutter kind of React-like. And then the layer kind of built on top of this is going to be a lot of stuff around, well, now we have this like rendering pipeline-y stuff. We're going to need to build up a whole bunch of widgets. And then once we have the widgets, then we'll need some nice entry points. So there's maybe a couple of layers about this. But I think this is a good start. And at about almost exactly 2 hours, I'll leave it there. And hope to see you next time. Thanks so much.